So we'll look at another example of using the present value of an annuity formula in terms of a loan. So annuities are really how registered retirement income fund works. If you're looking at retirement rates and things like that, a lot of life insurance companies and brokerage firms look at annuities as well. You can think of maybe loans like an annuity as well, since there's regular payments at the end of a payment period. You're given an interest rate, principal amount, etc. So you can think about loans in terms of looking at the present value formula of an annuity. So let's do an example of looking at that. So for example, a $1,000 loan will be paid monthly over 1 year at 6% per year compounded monthly. What would be the payment amount? So again, similar to one we've done in the past, we have the present value, which would be the $1,000 loan. That would be the original loan, and we'd like to know what our payment amounts are going to be. So we do have to do some manipulation with our formula. So I'm going to first bring I to the other side. So I times present value is equal to our payments multiplied by our bracket. And then we can bring this bracket to the other side as a divide to get a manipulated formula that our payments are I times present value divided by this bracket. So let's take some time to interpret what's happening within our question so that we can determine what we have to calculate for our formula. So with a $1,000 loan, we're going to treat that like our present value. It will be paid monthly over 1 year. So we're looking at 1 year in that capacity. 6%, so that's our R value, so 0.06, compounded monthly, which would be 12. And remember that we are using a time frame of 1 year. So in the end, our I value is going to be R divided by M, which is 0.06 divided by 12. And our N value is M times T, which ends up being 12 times 1, which is 12. And then we can substitute in our present value, our I value, and our N value. So I is equal to 0.06 divided by 12 multiplied by our present value of 1,000 divided by 1 minus 1 plus 0.06 over 12 to the exponent negative 12. So our multiplication on our numerator, you end up getting 5 come out there divided by, and again you can do some intermediate computations down here. I'm just going to get to where I did my partial one, so 0.05809, etc., etc. Trying to keep all your decimal places in your calculator, you should end up getting a payment value of 86.07 as your payment over that year with the rate given in the question.